nothing but we are going to combine this alphabets or symbol to create this string. And then language is nothing but it's a collection of string. Okay, when I say language is a collection of string, you have to do set self study by yourself. Set is nothing but a collection of elements, right? Now language is a collection of string. Hence language could be represented as set, but how to write a set means always within this curly bracket. Okay, that's why in the question we have just seen in the slide, L has been written as the set using this curl bracket. Okay, so oh sorry. So why I'm using why I'm presenting representing language as set means it is a collection of string. Hence, by the definition of the set, language can be represented in set form. Now, let me take one example about this alphabet, symbol, strings, and all. Now, let me take one example. Okay. Example summation. Summation is representing either input symbol or alphabets in our mathematical definition of deterministic finite automata. Remember last class. So summation, right? Let me. This is also a set. This is also a collection of elements. So let me just take A, comma B, comma till Z. Okay. This is nothing but this is called as alphabets. I have written here. And then using this, based on this summation or alphabets or symbols, collection of symbols, I'm going to generate certain strings. Okay, strings are the combination of these symbols or alphabets. So let me generate some strings. A, B, O, comma, BOY, boy, because I'm using these elements from here. And then YATCH, yacht. Then ZEBRA, zebra. OATS, ought. Then NNNT, comma. TTPS, comma. APPLE. So uncountable, I mean infinite number of strings you can generate it using these symbols. Okay. Now strings I have created. Some of these strings are useful to us, some of these strings are not useful. When I say about useful, it means meaningless. No, wait. I mean meaningful one, useful for our purpose. Okay, say for example, I just want to teach my toddler A for apple, B for boy, and all. So, what are the things to be included? What are the things to be chosen from this part? Means boy is useful to me, apple is useful to me, yacht is useful to me, zebra is useful to me, right? So, rest of the strings, right? Yes, we can able to generate it using this alphabet, but they are not helpful to me for my purpose regarding related to my application. Now from these strings, right, let me generate a language. Language. Language is nothing but a collection of strings. So whatever strings I have generated here, right, I have to write here. Okay. So infinite number of strings can be generated using this alphabet. And then there are types of language. There are, I mean, with from this example, right? Alphabets I have shown here, strings I have shown here, language I have shown here, and then within this language, right? There are two types. One is known as finite, another one is known as infinite. So let me explain this finite language and infinite language. I have already told language. Let me represent language 1 or in short L1. Next one is L2 or language 2. In this case, right, I have told that I have a toddler. I just want to teach him A for apple, B for boy, and all. So whatever the string generated in here, right, the useful one for my purpose are A, P, P, L, E, apple, boy, cat, etc. till zebra. Till zebra. Okay. Now, using these alphabets, I have generated lots of strings here, and then using these strings, I could develop two types of language. One is L1, one is L2. L2 is countable. L2 is countable and finite. Because numbers you could count it and then it's finite. Hence, this such kind of language is known as finite language. And then these strings, right, they are all infinite because many strings could be generated from this alphabet. So this language, right, they are going to have infinite number of strings, maybe useful and both unuseful one. So this is known as infinite language. Okay. Now let me move back to the slide. Let me move back to this slide. Now in this slide, this part I have already explained, language, strings, alphabet or symbol. Now, my target for today's class is we are going to learn how to design a DFA, deterministic finite automata, for all this example taken here. I have taken 5 examples today. I'm going to draw this 5 diagram in this class, in today's class. Now, in order to design the deterministic finite automata, I have to understand this language, which are a set of all strings of language, this part I need to understand. So in order to understand this language formation, right, I have written here. Okay. For this language, we need to design a deterministic finite automata. So before we design that deterministic finite automata, we have to understand. Understand the language first. So now let me just generate this language. Now, as per the example number 1, as per the example number 1, L is equal to set of all strings of length greater than or equal to 2. Right? Let me just, one of you please, who's this Tangsua something, please unmute your mic. Tangsua, I could not see your full name. Tangsua, please unmute your mic. Okay, first one is L is equal to, inside this curl bracket, set of all strings of length less than or equal to 2, where summation is 0, comma 1. Less than or equal to, sorry, this one is wrong. So let me just do. Counselor, please mute your mic. Tangsua, please mute your mic. Or else shall I just move you out from the classroom? Consulia Nike, please mute your mic or else I'll just lock you out from this class. I mean, I'll just deny you out from this class. Where is this Tangsua? Okay, now I need to understand. Now, let me tell you one more thing. Where summation is equal to 0, comma 1. Now, it's not a fixed one, okay? The summation may be of, summation is representing the symbols or alphabets. It could be of A, comma B, it could be of 1, comma 2, it could be of 3, comma 4, okay? For my simplicity purpose, I have selected only symbols 0, comma 1. So now I have already told that language is nothing but collection of strings. Now, what kind of strings we need to generate here? Set of all strings of length less than or equal to 2. Set of all string of length less than or equal to 2. But the string has to be a combination of 0 and 1. So let me write the string. Summation means empty string. Okay. Empty string, null string is represented by epsilon. Summation is less than, the length of summation is 0, which is less than or equal to 2. Hence, it's included here. Next one is 0. Length of 0 is 1. Hence, it's included in here. Next symbol 1. Yes, length of this string is 1. Hence, it's included here. Next one is 0, 0. Length of this one is 2. Length of 0, 0 is 2. And then as per this set description, less than or equal to 2. This is equal to 2, hence it's included here. Next one is 1, 1. This is fine. 0, 1, fine. 1, 0. So set of all strings, I mean all the possible combination using this symbol 0, comma 1 has to be included in this language. So L1, right? I mean, not L1. As per the example number 1, L is equal to set of all strings of length less than or equal to 2 where summation is this. Okay. Now, this example number 1 language, right? I have generated the possible strings here. Now, as per this slide number 1, in my case, as per this slide number 1, I need to design the deterministic finite automata for this particular language. Now, in order, I have considered only this language one, this one here. For this, let me draw the DFA. For this, let me draw the DFA. For this, let me draw the DFA. Okay. Now listen very carefully. You can find the tips from the textbook also, but it's very, once you understand, it's very easy. But it's not understanding, then it's not that easy. Okay. So I'm going to draw the DFA. So listen very carefully. I'm going to design the DFA of this language L. Okay. So in the case of deterministic finite automata, you need to have only one initial state. Okay. And then you need to have one initial state. It's like a state diagram which we have already learned in last semester. Let me explain to you. You need to practice a lot so that it will come easily. Wait. I have made a mistake. Okay, let me. Instead of writing it all by myself, I'll just explain to you guys. I need an initial state. So this one, right, I'm going to make as an initial state Q1. Now from this string, right, select the string with least length. Out of this string present in this language, select the string with least length. So when I compare this, epsilon is having the least length. Length of this epsilon is nothing but 0. So now let me rub this another example, another state also. Let me explain one by one, and then that way you'll be understandable. Okay. Now, in order to designing a DFA, right, your machine should accept this language. But how to design a DFA for this language means this language is nothing but the collection of these strings. So out of these strings, select the one string who is having the least length. Out of these strings, epsilon is having the least length. So the initial state, right? Initial state, please make it as the final state. I don't know whether you're understanding or not. Double circle will be representing the final state. It's not double circle. Okay, double circle. Okay, if you make the initial state as the final state, then this itself is representing that this machine is accepting epsilon in the case of DFA. I'm talking about deterministic finite automata. In the case of non-deterministic, it is again a different way. So in the case of deterministic finite automata, if you want to make that machine to accept the epsilon, then make the initial state as the final state. Okay. Now next one is again select the least length string. This one is already done. So next one is either 0 or 1. So let me select 0. 0 is having length 1. 1 is also having length 1. I have to select either of this. So let me select 0. So the machine should accept 0. So it will start from Q1. Then it will move a whole, okay, 0. Then when I say accept means the final state should be, the ending state should be the final state. Then only you can say that this machine is accepting 0. That's why I'm making next state is final state. So 0 is done, and then 1. 1 also, like you can keep the level as 0 comma 1. So whether the machine is accepting 0 1, yes. Okay, from initial state, if you provide the input as 0, if it is performing the transition from Q1 to Q2, and then Q2 is the final state, hence it is accepting. Okay, now next one is either you can select 0 0 or 1 1 or 0 1 or 1 0, it's up to you. So let me select 0 0. Let me select 0 0. So let me select 0 0 0 0. So always it has to start from Q1. Q1, when the input symbol is 0, it will move to Q2. First 0 completed already there. Q2, when 0, it should be another state of final state. This has to belong to final state. Then only 0 0 will be accepted by this DFA. Hence, let me extend Q3 0. And this is done. Okay. Now next one is 1 1. So 1 1, let me again start it. It will start from initial state Q1. Q1 with input 1, it will perform the transition to Q2. And then Q2 with 1, I haven't provided. So let me insert 1 here. So 1 means Q3. Q3 belongs to final state. Hence what 1 1 is being accepted by this DFA. Now next one is 0 1. 0 1. Initially, it will start from Q1, input 0, then it's Q2, 1. Yeah, 1 is already there, hence Q3. Q3 belongs to final state, hence 0, 1 is being accepted. So this is done. Next, 1, 0. Next, 1, 0. Initially, it will start from Q1, input 1, then Q2, Q2 input 0, Q3, and then Q3 belongs to final state. Hence, this machine is accepting this one. And one more thing, our target is to design a DFA, deterministic finite automata, which accept this language. While designing a DFA, wait it 1 second. Okay. While designing a DFA, right, you should provide the part of those languages whose slang is more than 2. Whose slang is more than 2. Because as per the example, right, we should design a DFA which accept the string having length less than or equal to 2. But if the string of length is 111, this has to be rejected. But how to check whether a given string is being accepted or rejected means the ending state. Like in this case, I have already informed 0 0 is being accepted means Q3 is one of the final state, hence accepted. Q3, all are part of final state, hence accepted. Now, if the length is more than 2, 0 comma 1, Q4, then it will not accept. So let me just check. 1. It will start from initial state Q1, 1, then this is Q2, then 1, Q3, then 1, Q4. Q4 is not final state, hence this one is being rejected by this machine. Our target is to design a DFA which will accept this language but which will reject other than this language. Then what about 1111? What about 1 1 1 1 1 1 like that? So for that one, right, let me have provide a self loop here, 0 comma 1. Okay, so this is the required deterministic finite automata. So let me repeat you a few tips. While designing a deterministic finite automata, you need to have only one single initial state, but you can have more than one final state. And then for each and every state, like how many states are here, Q1, Q2, Q3, Q4, for each and every state, you need to provide the path for this symbol, for both the symbol. You need to provide the path for both the symbol. So in our example, the symbols are 0, comma 1. Hence, every state needs to provide the path for these two symbol. This is the requirement. This is the checking part while designing a DFA. So let me check whether we have provided the path for these symbols. So there are how many what states? There are Q1, comma 0 symbol, and then Q1 0. I mean, oh sorry. Q1 1, and then delta Q2. This is transition function. Remember, delta Q2 comma 1, delta Q3 comma 0, delta Q3 comma 1, delta Q4 comma 0, delta Q4 comma 1. If you are providing the possible path for all the states of both the symbol 0, 1, then definitely you're going to have a transition state here. So Q1, in the current state is Q1 with 0 input, Q2. Current state is Q1 with 1 input, Q2. Current state is Q2 with 0 input, Q3. Current state is Q2 with 1 SD input, Q3. Current state is Q3 with 0 SD input, Q4. Current state Q3 with 1 SD input, Q4. Current state is Q4 with 0 SD input. Oh, sorry. It's a self loop, hence Q4. Again, this is also Q4. Okay. So first one is completed. First one is completed. Now let me move back to this slide. Let me move back to this slide. Next one is set language with length greater than or equal to 2. Language of length greater than or equal to 2. Here, example number 2. Example number 2. L is equal to set of all strings of length greater than, oh, I'm confused, greater than or equal to 2. Greater than or equal to 2. And then summation is equal to 0, comma 1. Okay. Now for this one also, I'm going to design the deterministic finite automata. So let me generate the language first. In this case, the length should be either equal to 2 or less, or greater than 2. So let me write 0, 0 is equal to 2, 0, 1 is greater than, equal to 2, 1, 0 is equal to 2, 1, 1 is equal to 2, 1, 1, 1 is greater than 2, 1, 0, 1 is greater than 2, 0, 1, 1 is greater than 2, like that. Okay. Now I'm going to design the DFA. So obviously we need to have an initial state. So let me just write an initial state here. This arrow is indicating that this is, okay, I forgot to write the definition of the previous example. So let me write the definition for this example. That way you can learn it. So I need to have an initial state. So Q1 is the initial state. Now, again, the same way, select the least string, select those strings which are having least length. So when I check, it is 0, 0, 0, 1, or 1, 0, or 1, 1. So either one you can select it. So this machine has to accept 0, 0. Hence, let me write 0 here, Q2, Q3, 0. Okay. So, if you want this machine to accept 0, 0 means make Q3 as the final state. Make Q3 as the final state. Okay, done. I'm not repeating from the basic. How to check means 0, 0, Q1, Q2, Q3 belongs to final state, hence 0, 0 is being accepted. And then next one, 0, 1. For 0, 1, right? 0 is already there, par is being provided. 1, you just add it here. So it is accepted. Next, for 1, 0, just insert another level here. 1 and then 0 is also there, accepted. Next, for 1, 1, no need. For 1, 1, no need. 1, 1, initially from Q1, input currently at Q1, input 1, then move to Q2, currently at Q2 with input 1, then move to Q3. Q3 belongs to final state, hence it's being accepted. So for all this string having length 2, DFA is being defined. Now, as per this language, right, if the length is beyond, more than 2, then it has to be accepted. So triple one has to be accepted, 4 number of ones has to be accepted, 5 number of 1 has to be accepted, right? So for this one, right, let me just insert one self loop here. Self loop means infinite number of zeros and ones you can pump in. If you keep on increasing the number of zeros and ones, the combination also will be accepted. But one more thing, this is the major confusion here. Many people will think that, I don't know whether you guys are understanding or not. Any of you, if you're having any confusion till now, whatever I have taught, please unmute your mic and just inform me. Unmute your mic and please inform me if you have any issue. Then no one is raising the doubts, then I'll just think that you're understanding everything. Okay. Now let me check for triple one. 1, 1, 1. It will start from Q1. Currently at Q1, input 1, Q2. Currently at Q2 with input 1, Q3. Currently at Q3 with 1, it will remain in Q3. Q3 belongs to final state, hence it's being accepted. Now, yesterday we have seen the mathematical definition of deterministic finite automata. Remember that 5 tuple 1. So for that, right, let me just remind you, they say that one capital Q summation, then initial state Q naught, then transition function, then this. Okay. Now let me write the mathematical definition of this example DFA. Let me represent this machine as M is equal to how many states in here? Q1, Q2, Q3. Next summation as per the question 0, 1. And then as per this example, as per this DFA, initial state is Q1, hence instead of writing Q naught here, just write Q1. And then transition, let it be for the time being this one. And then F, how many final state? Only one. This has to be represented as set. Okay. And then where delta, then you need to write for all these states 0, Q2, delta, delta Q1, 1, Q2, delta Q2, comma 0, Q3, delta Q2, comma, sorry, 1, Q3, delta Q3, comma 0, Q3, delta Q3 comma 1 Q3. Okay, this is the second DFA for the second language. Now, next example, the third example. Third example. Example number 3. Let's move back to the slide. Example number 3. Set of all strings of lang is equal to 2. Set of all strings. L is equal to set of all strings of lang is equal to 2, where summation 0 comma 1. Okay, now for this one, right, I'm talking about the strings of length exactly 2. Hence 0 0 0 1 1 0 1 1. For these two combination, we can have only this much. Okay, now let me design the DFA for this. So obviously I need to have an initial state. So Q1, let me try out for 0 0. So 0, Q2, Q3, 0 0. So just check whether 0 0 is being accepted by this machine. Q1, current input symbol is 0. Q2, then 0, then Q3. Q3 belongs to final state, hence accepted. Next one is 0 1. 0, the path is being provided. 1 is not provided here. Next one is 1 0. 1 0, you just add 1 here. Next 1 1. 1 1, no need, already there. Okay, so this is the required DFA. So for this one, right, I will not write the definition like this, but in exam, if I ask you guys to design a deterministic finite automata, you have to write the definition and not like this. What I have done in the case of example number 2. Okay, what I have done in the case of example number 2, you have to do like this, writing the mathematical definition of the DFA. Now let me take example number 4. Example number 4. Example number 4, set of all strings of length greater than 2. Set of all strings of length greater than 2. L is equal to set of all strings of length greater than 2, where summation is equal to 0 comma 1. Now let me generate the string whose length is greater than 2. Equal to part is not there. So 0 0 0 1 1 1 0 1 1 1 0 1 1 1 0 and so on. Okay. Now you could, for designing the DFA, right, you can select either this or this or this or this or this. It's up to you. It's your choice. So let me start with this. You need to have an initial state Q1. Initial state, it's up to you whether you can have, as you can write it as Q0 or Q1 or like that, okay? But follow some rules or some patterns. I'm following Q1, Q2, Q3 like that. If you want, you can keep on following Q0, Q1, Q2 like that, okay? 0, Q2, 0, Q3, and then final state, Q4. 0. So this is being accepted, 0, 0, 0, because last is the final state, hence being accepted. Now, triple 1, 1, 1, 1, accepted. Now, 0, 1, 1, no need to do any modification. 0 is here, 1 is here, 1 is here. 1, 0, 1, 1 is here, 0 is here, 1 is here. 1 1 0 1 1 0, it's here. And then if you keeps on increasing the combination, the length, right, it has to be accepted. Hence, provide a self loop here. Okay, this is the required DFA for this one. This is the required DFA for example number 4. Now, Next one is less than 2. Less than 2. Less than 2. Jump. Oh, example number 5. L is equal to set of all strings of length less than 2. And then summation is equal to 0, comma 1. So I need to generate the string for that one. Less than 2 means epsilon is included, 0 is included, 1 is included. That's it. Now see here, I'll select this one first. You need to have an initial state, Q1. If you want deterministic finite automata to accept epsilon, then make initial state is final state. So epsilon is being accepted. And then next one is 0 has to be accepted. Q2, 0. This is accepted. Next one, this. What about 0, 0? If it is more than, if the length is equal to this one, if the string length is equal to 2, this has to be rejected, right? 0, 0, 0 has to be rejected. So while designing a DFA, we need to provide the path for all those strings which will be rejected by this machine. So hence this is the required one. And then one more thing, let me move back to the previous example. In previous example, the set of all strings of length greater than 2 has to be accepted. What about the less than 2? Less than 2 will be rejected. Let me just check it. In this machine, less than 2 means 0, 1. So let me check. 0 initially at Q1, and then currently at Q1 with 0 input, it will be Q2. Q2 does not belong to final state, hence 0 is rejected. Rejected. Okay. While designing a DFA, you need to provide the path for all the symbols present here, and then you need to provide the path for the rejected language also. You need to show that such language will be rejected like that. Okay. And then what about this? In this part, set of all strings of length is equal to 2. If suppose if the length is more than 2, if the length is more than 2, if suppose 0, 0, 0, then 1, 1, 1, it has to be rejected. So this one, right? Q4, see, it has to be joined. Okay, an example, in exams and all, many people used to create as, unjoined one. So this is completed. Example number 2. Example number 2, if the length is greater than or equal to 2, if it is less than 2, it will be rejected or not? Yes, it will be rejected because it will not be reaching the final state. Then rest, I guess, completed. Now I have drawn the, my today's class, my target is to design the DFA for these 5 examples. I have designed it. And then after learning how to design the deterministic finite automata for this language, finally, we are going to derive a formula. Like in GET exams and all, right? They'll ask you a few questions like, if the string length is this, for designing a DFA, how many states will be required? In my, this tips, few tips, right? And is representing number of states, okay? And is representing number of states. So I've written a few, formula here, n plus 2, n plus 1, n plus 2, like that. So this one, right? Let me do something here. Let me take this one. When the length of the string is equal to 2, when the length of the string is equal to 2, then we require n plus 2 states. We'll just move back. When the length is exactly equal to 2, when the length of the string is exact, yeah, this one, okay. when the length of the string, if the length of the string is equal to 2, as per the formula we required n plus 2 states. Okay, how is that one? We'll see. Length of the string is 2, and then n plus, wait, 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 you'll get confused. If the length of the string is equal to n, then you need n plus 2 states as per the formula. Now, how it has been derived here means, in this example number 3, string of length 2, n is equal to 2, then this is 2, 2 plus 2, 4. So in this DFA, how many states required for designing W length is equal to 2 means 4. 1, 2, 3, 4. That's why 2 plus 2. Okay. If you want, you just note it down, or you just want to save as a screenshot. This is the formula. In GET exams and all, they'll ask the question. In GET exam and all, like if the length of the string is equal to 3, how many states will be required for designing the DFA and all? Okay. Or else, if you want the slides, I'll just upload it in G class. Okay, thank you. That's the end of today's class. And wait a second, wait a second. Do not leave, okay? I'm taking attendance. Those who left, I don't know. Okay, okay, fine. Okay, fine. Thank you.